Hello viewers. In this short video tutorial, I will take you through few examples that will help you understand how seemingly theoretical concepts in the probability and statistics space can be really applied to solve practical real-world problems. Specifically, I will spend time going through concepts, conditional probability, and Bayes theorem, which are the core and foundational concepts in the area of probability and help you understand and help you relate with how these form the foundation for some of the machine learning algorithm. Let's start with the concept of conditional probability first. Now, if we just go by the definition, conditional probability tells us that given two events A and B, the probability of event A given that the event B has already occurred is given by this expression. And this is again a pure mathematical expression. And till the time we do not see a real world example, we may not be able to relate very well with it. So here comes the real world example. And what we're looking at here is email information and what kind of words appear in emails. And just for context, I'm showing you two emails wherein I'm showing you that there is a word free that occurs. So this is first email. And in this second email, the word free does not occur. And what we are trying to do is maybe devise a mechanism where based on this word free occurring in the email body, can we classify or detect the email as spam or not? And after a certain point, I want to take you to a place where I can really connect the dots and show you that in a way, conditional probability lays the foundation for devising such a mechanism. And in the process, we'll learn more concepts in the probability area. Now, proceeding further, let's first look at how this expression gets modified in this scenario. And again, I will use the conditional probability understanding. That is, can I know the probability of an email being spam given in the email body, there is this word free occurring. And if I just apply the formula, I get this proportion. Now, we need to do this computation and come up with the probability numbers. And that is where let's start looking at the information as well. Here I'm showing you a table where there are some sample records and assuming these are 10,000 rows, 10,000 records in total. There are two attributes, there are two columns. The first column indicates whether the email has the word free or not. So 0 indicates that there is no word free, whereas 1 indicates that the email does have the word free. And for that corresponding record, we have the label as spam or not spam. So this essentially tells us that whether that email is a spam email or not. So this is a table, which is what in the real world, how the data looks like. And let's assume that these are 10,000 emails in total. Now, the first thing that we want to look at is out of these overall 10,000 emails, how many of these had the word free? And then how many of these emails did not have the word free? So that is where we'll arrive at these two subgroups. And further, we will want to know for each of these subgroups, how many of the emails were spam or not spam. And just to give you a perspective, I'm also going to show you the numbers that we achieve once we start breaking down this number to 10,000. So this number 10,000 gets broken down into 2,000 and 8,000. And then further, when we do the identification of the email as spam or not spam, we get these numbers also. So out of these 2,000 emails, 1,600 emails was identified as spam, which had the word free, and 400 emails were identified as not spam. Again, these emails did have the word free. Of the 8,000 emails which did not have the word free in them, 200 turned out to be spam emails and the remaining 7,800 turned out to be not spam. Now, this is a good way to see how the numbers really break up, and then we can look at the count for each spam and not spam based on the word free occurring or not. But a more conventional way, a more proper way to look at this information is a contingency table. And here is one based on these numbers. Now, using this table, we are going to arrive at the probability that we wanted to compute. So we want to know what is the probability that email is both spam as well as free. And if you look closely, this is the number that is indicating count of emails where the email is spam as well as it has this flag 1, which indicates that the body has the word free. So we will have 1600 divided by total emails, which is 10K in the numerator. And since this is a probability, we'll write the expression like this. As denominator, we would want to look at the probability of an email as having the word free. And if you look closely, we want to look at all these instances of emails because these are the emails where the word free appears. So we'll write the expression, which is the total of these two numbers, 2000 divided by 10K. And you can see that 10K cancels out from both numerator and denominator. And ultimately, we get 16 upon 20, which is 4 upon 5. So 0.88 is the probability where an email would be a spam email given the word free occurs in the email body. Now, this is basic layout, basic understanding of conditional probability, how it is applied to solve this probability-based question in a real-world example. But this itself is not enough. And we want to go to the next piece where we want to look at how we can incorporate more attributes so as to make this mechanism of identifying email as spam or not more robust. And that is how real world machine learning models are built. But again, we need to learn something more, something extra. And that is exactly where Bayes theorem comes in. Now, these expressions are familiar to us because we've already covered the topic of conditional probability, just that they talk about different kind of probability computations. So on the left, we are saying probability of event A occurring, assuming event B has already occurred, whereas on the right, we are saying probability of event B occurring given event A has already occurred. And in both these expressions, if you see closely, the numerator part is common. And if I want to combine both these expressions just to see how the interaction really works out, I can use this numerator part and then put the remaining components in the same equation. And if we ignore this part, we are then left with this remaining expression. And if we again just move the terms here and there, we can actually come up with this expression, which does not use the intersection term, which was being used earlier. Now, this modified expression is the Bayes theorem, and it involves the additional knowledge over and above the prior knowledge we have. So we have these as prior knowledge, what we already know. And this part is where we get new evidence. And based on this new evidence, we want to update our belief. So this is essentially what Bayes theorem brings to the table. And as you can clearly see, it does use conditional probability as its base. But again, how is this expression really useful? Let's go back to our example of email classification as spam or not, and try to apply this expression. And as you can see, based on what we had as the information, the labels also have changed. So LHS, which is this probability expression, remains the same, but we have updated the RHS, and now there is no intersection term on the numerator side. Rather, we are computing the product of two probabilities. And we can use the same old contingency table to come up with all these numbers. And let's do that step by step. So for the numerator part, we'll first try to derive this probability, which is probability of email containing the word free given it is spam. And for us to really come up with this probability, we have to look at this contingency table and look at of all the spam emails, which is of all these 1800 emails, which are spam emails, how many of them had the word free? And you can clearly see that 1600 of these 1800 emails had the word free. So I can simply write 1600 divided by 1800. This gives us the probability for this component. For the other component, which are the priors, we would simply do a check of how many emails are spam compared to the overall emails. So we'll just simply count the total number of spam emails. And for us to get there, we'll just do a total of these two numbers, which is 1800. And we will divide it by the number 10,000. And lastly, we'll compute the denominator. And it's kind of straightforward. We'll just need to find how many emails had the word free. And if we were to do this total, we'll get that number, which is 2000. And we'll divide that expression by 10,000, which is the total number of emails. And if you look closely, some of the terms do cancel out. So specifically, we can cancel out this 10,000 with this, and we can cancel out 1800 here with this number 1800 out here. And ultimately, we are left with the two numbers 1600 and 2000, which again gives us the probability as 16 by 20, which is 4 upon 5 and then 0.8. So this is the same number that we got earlier. That is, while we looked at the concept of conditional probability, just that compared to earlier, we are now using the Bayes theorem. So far we have been able to clarify that Bayes theorem gives us similar results, and now we do not need to use that intersection term that we were using earlier in the numerator. But how is exactly this helpful? When we add more attributes to our mechanism of identifying email as spam or not, that is where the utility of this expression becomes evident. Now, if I can just show you the extension of this example, wherein we have two attributes now. And essentially, these are indicators of the email body containing the word free, 1 and 0, or the email body containing the word win as 1 and 0. Now, in such a case, I would need to incorporate both of these attributes to really come up with the probability of whether the email is spam, given we are observing the word free and win in my email. So this is what I really want to predict based on my historical data. And what we have just learned is using Bayes theorem, and that theorem is going to give us some expression. It is going to be a collection of terms. And by applying all these terms, we would be able to come up with a final probability. Now, this is the base, this is the foundation that machine learning models like Naive Bayes use in the real world. And quickly, what I can do is, as a part of conclusion, I can just show you how that expression finally turns up. So this is the expression that gives us the probability of email being classified as spam, given the words free and win appear in that email. And like I told earlier, the expression on the RHS is something that we derive using the Bayes theorem. Now, we would need to learn an additional technique called as Naive Bayes that will further simplify this expression, and this will help us ease up the calculation to a certain extent. Again, due to the limitation of scope of this video, I will not really go there, but what we have been able to do is lay out the foundations using these core fundamentals of probability so that it becomes easier for us to learn more advanced concepts in machine learning, such as Naive Bayes. Thanks for your time.